this is Passy from Passy's World of ICT, the guy with the white hat. And today's VB lesson, we're looking at the selection sort algorithm and the quick sort algorithm. And this is kind of getting into some computer science here. And we're going to code the selection sort and show you exactly how it works. So let's get on with it. All right, let's go. So why do we need to sort data? What's that all about? Well, sorting is extremely important to create easiness for users to find things in lists and to scroll down through them. So when we did the doctor appointments, okay, in a previous lesson, what we had them in sorted order. So you'll notice here that the appointments are sorted. We had descending date, so we got the latest appointments first here in the list. And then we had time ascending, so that on the 22nd of the 5th here, the same date each time, it went from 9 a.m. then 9:30 a.m. So it kind of started at the beginning of the day on a certain date and progressed forward through the day. So that made it easiest to scroll down and look at appointments, and probably you wanted to know recent appointments rather than old ones, and that's why we had to do the descending date, the kind of opposite order to usual. And that was just a one-liner in VBNet. It was so easy to sort this results data grid table because all we had to do is put this default view sort, and that uses VB's internal sort function, and we just wanted to say what we wanted to sort on. So it was the appointment date field descending and the appointment time one ascending, ASC. So yeah, VB has this beautiful one-liner built in, which makes it great and easy to do all our sorts. But we'll talk about that later on a bit more. Sorting is also important when you want to apply a file of transactions to kind of a master file or a master file of customer balances on customer records. So if we sort the transaction file so that both things are in the same order. So if we sort on customer ID, although often customers have an account number and that's the primary key, that's their ID, it's going to be a lot faster. So in this master file processing, what happens is that you have your customers here sorted in account number order, okay, and then the transactions that you need to update this file with, they're sorted in the same order. So straight away, it'll start at number 100. It finds, oh yeah, there's a 100 here. Let's add 2714 on here, and so on. When it gets to 500 Sam Sharp, there isn't a 500, so there's no transactions for him today. But yeah, it can do it really quickly if they're sorted in the same order. So that's really important as well. And that master file processing sort of thing is done a lot in banks and telcos, companies where you've got a whole bunch of transactions for 1 hour or even one whole day, and you've got to process them onto your customers and update certain values. Okay, now sorting algorithms in VB, as we saw, it's so good. You only have to write one line of code to do your sorting. But behind the scenes, inside that function VB's using, it's actually running a sorting algorithm, and that's what we're going to look at here, the sorting actual algorithms, because there's quite a few different ones. So just like there's many different kinds of cars driving on the road, and some are higher performance than others, okay? There's many different sorts as well, and some are really high performance sorts, and you need those for really big data like you'd have in major companies like banks and telcos, and they've each got different processing algorithms. So 3 of the common sorting ones you'll meet in a typical computer science software development course are selection sort, and that one we're going to explain. We're actually going to write a VB program for that and show you all about how that one works. The other one is quick sort. Now we're going to explain that one, and we'll show you a VB program that someone else has, because we didn't have time to do one ourselves, that does the sort. So you'll be able to create that one in VBNet as well if you want to. Now a lot of courses do bubble sort, but we haven't got time in this video to cover bubble sort, but maybe another time we'd like to make a whole separate video just on bubble sort and show you that algorithm, but we don't have time today in this lesson. And in the course that we're teaching for the Victorian software development course, the 2 sorts they have to know, students have to know, is selection sort and quick sort. So we're covering those ones. Bubble sort would have been nice to put in, but we didn't have time, and it's not in the course we're currently teaching, so we've left that one out. Okay, selection sort is the simplest of all of the sorts, I'd say, and it's easy to understand, and it's very easy to code in VBNet. All right, so However, there is one thing about selection sort which you need to be aware of, especially for exam questions, and that is that it's horrendously slow on large data sets. So big business would not use something like selection sort because they're data sets that have thousands or even millions of records. It'd be way too slow to try and sort them with a selection sort type algorithm. Okay, so that's something you need to be aware of. So there's many different sorting algorithms in computer science, and some are a lot more complicated, but they get much faster results. Just like a Grand Prix car is an incredibly complicated piece of technology compared with a bicycle, but the Grand Prix car will perform a lot higher and obviously go a lot faster because of that, okay? So that's what you need to realize. It's kind of the same deal with sorts. So quicksort, which we are going to look at in this lesson, that's one of those more complicated sorts, and it generally gives solid all-round speed and efficiency, okay? And most of the sort routines that are built in, like that one-liner that's built into VB, which goes to a function behind the scenes, and other languages, they use quicksort or some variation of it, usually as their sorting algorithm. So it's a very common one, the quicksort. But let's do selection sort first because that's a simple one, and we'll start with that. So the idea with selection sort is that here we've got some indexes of the array, the first position 0 as per VBNet, then 1, 2, 3. So I've only got 4 numbers here, and we've got 7, 11, 5, and 9. So the idea with quicksort is that it scans along all of the data here, and it finds the smallest value. So when it scans along, it should find that the 5 here is the smallest number value. So in the first pass, it goes right through and finds 5. Now, because 5 was the smallest one, it swaps over 5 with the 7, so that 5 will now get moved to the front as the lowest value, or to the top of the array, if you like. So what happens after the first pass is that 5 has been moved to the start of the array, and where 5 used to be, we've now got the 7. So we just swapped the 7 and 5 around. So that's ticked off, and we don't visit index 0 again. All we need to do now is look at the remainder of the array, the 11, 7, and 9, and we scan along here and find which one is the smallest in here. So the smallest one is 7, so we swap that with the one that is at the start of that group. So 7 and 11 are going to swap places. That's what's happening in the selection sort. So they have swapped places now. 7 is right here, and that 11, which used to be there, has been moved across to where 7 was. So they've just swapped around, and these two we've ticked off as done. So we don't need to revisit index 0 or index 1. We've just got the last remainder here of the 2 and 3 positions to do. So again, we scan along there and find that 9's the smallest one. So 9's going to swap to the front, and 11 will jump over there where the 9 was. And when we've done that, there's only one item remaining. We're at the end here when we go to scan. So the values are all in sorted order, okay? Now, because we started off with 4 values, it took 4 passes to get through there and had to do quite a bit of scanning and locating of smallest values. So it's simple to understand. And look, on the data sets we're doing for our little project, selection sort is fine. But if you needed to, process 100,000 kind of online banking transactions or 1 million customers overnight or something like that, selection sort would be hopeless, okay? Because you've just got to keep scanning through that 100,000 records lots and lots of times, okay? Even though you're moving along one each step, each pass, that'd be lots and lots of scanning and take a lot of time. Okay, so there's a video visualization of selection sort, kind of like we just showed you, which is really good and shows it quite well. And that only takes 3 minutes 27, but look, it's a bit slow. So on that tools cog here, just put it up to 2 times speed, and then it's only going to take you about 1.5 minutes to watch. And that's the link there. Okay, so we'll put these links in the video description, but that's a great video to watch. Now, the simplified algorithm of what we were doing with that selection sort is basically we were setting the minimum value at the start there to location 0, this very left-hand side start of the array that we had there on our screen. And then we were repeating steps. So we searched all the way along and located the minimum element in our list. And then we swapped that one round with the one that was at the start there, so that we then had the smallest one at the front. Then we incremented our minimum value by 1 so that we were the next place along. and did the same old sort of thing again. So we kept repeating these steps here of searching along what ever was left, find the smallest one, bang it over to the front, swap it with the one where it was. And we do all that till we reach the end of the array. Okay, so that's kind of a high level simplified view of the algorithm. And if we want a fuller view, here are some more kind of pseudocode type views of what needs to happen there, okay? So we need to sort of, do a loop that can scan through the data and move that loop along by one each time until we've scanned the whole lot with many passes and we've got everything in order. Okay, so let's have a look at our VBNet program. So first we're going to make a form. So this is the form we're doing, and we'll have the unsorted data first showing up in a list box, and then the sorted data will show up in this other list box on the right hand side. Okay, so you need a form here that's got two list boxes. That what these big white boxes are here. They're list boxes, and we need two buttons down here at the bottom. Okay, and we've also put just a group box around those to make it look nice with no text in the group box, and of course we've got a label there for the heading. So name these list boxes. This needs to be list box unsorted, and this one needs to be list box sorted, and we've got that all in uppercase. So make sure you name them exactly the same, because that's how we're going to refer to them in the program code. And likewise with the buttons, BTN sort to do the sorting and BTN exit, and make sure you spell them just like this, because that's how they're going to be spelled in the coding when we do the coding. So let's get into the coding. So what we need is we need to just set up some numbers array here, and we're just going to have the numbers between 11 and 20 in unsorted order here. So we've got 10 items. Okay, and they're going to start at index 0 and finish at index 9, because remember VB starts counting at 0 rather than counting at 1. You should know that from our previous lessons. And we're just going to take that list box and put a little heading in it. Then we're going to just loop through this array, stepping through it, grab all of the values and add them in as items in the list box, all right? So that is just the first bit, to upload and get everything displayed in that left-hand side list box. So we'll test that and make sure it's working, all right? And so when we do that, here's our unsorted array, and everything's displaying in the order that we set it up when we dimensioned the array. So that's really good. So that's sort of how we're going to load a list box and get it displaying on the screen. So that's great. So now we need to just write the code for this sort button here, because they're going to be clicking that sort button, and then the results are going to go in this sorted data list box over here. So now we need to work on the code for that. So double click on that sort data button, and we add the following code, all right? So first we're going to have the lower bound and the upper bound, which is kind of the lowest value in that array and the uppermost index value in the array. So in VB you use the L bound command and the U bound command, and that will find you kind of index 0 and what the last index is in the array. So then we're going to set up our loops, and we need I and J loops inside each other, and we're going to have our min value index, the one we're swapping with when we find the smallest value, and what that smallest swap value is, okay? And we're going to use a loop to do all of that. So this is what's happening here. We've got an outer loop, so that's going to start at the beginning of the array, and it's going to shuffle along 10 times, doing 10 passes altogether, because we've got 10 array items, okay? So that's going to be happening there, just to get us at some position to start on the array. And then we're going to have this other loop, the inner J loop, which is going to, once we're at that starting position for the I loop, it's going to go along through everything that's after that with this J loop and just check out what the values of those numbers are. And so first time through, we're going to have the swap value set to 0, because we just initialize that before we start looking along that particular array. And then in swap value, if it's the first one, and the in swap value equals that one. So first check for first time finding a smaller value, then check if it's the smallest so far. Okay, so we're doing that. Then here we're doing the checking. So this means basically if it's not the first time through, what we're going to do is that we're going to check, is the current number we're on less than that swap value, all right? And if it is, we're going to take whatever number we're on at the moment and put it into that in swap value variable, and also just record what the index was. So we're not swapping them around yet. We're just saying, oh, at the moment, the smallest one is located here. But we need to keep spinning through because there might be another one further along that's even smaller than this one, okay? So that's why we have to have these loops so that we can check every single value and make sure it's okay. So you can see this main one here, if the number we're on is smaller than that first one, okay, then we're going to do this. So on the first run through, we're going to just put it into the swap value and make a note of where it was positioned in the array. But if it's not the first time through, we're going to check, okay, we've already found one already and got it in swap value. Is this next one we've found actually smaller than the other one? And this is what we had a lot of problem with the coding, and it took us a while to get this working properly, because what happened was we only sort of had this part and this part. And so for something like 20, 14, 19, and 18, it would use 20 first, and it would say, okay, 14 smaller than 20. So to put that in swap value, okay, but then it go through the loop again and it go, oh yeah, 19 smaller than 20. So put that in swap value. And then when we got to the end, it would put 18 in swap value. So what would happen was it would say, think that the smallest one was 18, okay? And that was wrong. So what you need to do is after you've put it in swap value, you then need to compare with if there was something already there, is your guy smaller than what's already there? So 14 would have already been there. When you get to 19, is that smaller than what's already there? No, it isn't. So don't swap, don't put it in there. Don't record 19. And 18, is that smaller than the one you've already got it, which is 14? No, it's not. So don't put that in as the swap value, all right? So this coding just in here and here took a while to get, and we had to put a lot of program debug displays in. And if you get the downloads for this lesson, there is a listing of the code which shows all the debug displays, which will enable you to really see how this sort is working, okay? So then we've got this code here, and if the in-swap value is not equal to 0, when we've done our run all the way through going along with the J's, that means we must have found something that was small. So then we're going to actually do the swapping, okay? But if we went along and didn't find anything, well, then we don't do any swapping and we just move along to the next one. Or we might be at the end of the array by that time and it might be fully sorted, okay? So that kind of creates a stopping mechanism when it's fully sorted as well. Right, so then we just need to display what we've got. Now what we're going to do is each pass it does, we're just going to display the results in that sorted list box with a message for you to click OK. And that way you can kind of see the whole thing. It does the first pass, oh yeah, it's moved this one to here. Does the next pass, oh yeah, we can see those ones at the start are starting to get in order now. And you can sort of see step by step what it does. If you don't want it to do that, you can just take this bit out, and then, you know, it'll just display the final result, okay? So I've added some code there to display step by step as the sort's progressing, as you'll see in a minute when we show you the testing results, all right? So that's it. So if you didn't want the step-by-step displaying, you just need this one here. First, clear out the previous pass display and just display those, all right? So let's have a look at what it does. As we said, it took a while to get working because it was tricky to sort of get that algorithm so that we'd only keep the smallest one that it had found and not override it accidentally. So here we are. Here's our unsorted data at the beginning, and here is our program after it's done the first pass, and you can see what it did was it had 14 here, and it scanned along and found the smallest one that was smaller than 14 was 11, okay? So 11 got swapped up to the front, and 14's way down here where 11 used to be, right? And then on the second pass, it's skipping one along and starting at 13, scanning the rest, finding, okay, this 12 is smaller than 13, so I'm going to swap 12 and 13 around. So you can see 12's moved to here, and 13's moved down to where 12 used to be, all right? And one more, because we've done 11 and 12 and they're ticked off as sorted now, and we don't have to revisit them. We're starting at 20, And when we scan down, the smallest one that is smaller than 20 is actually going to be 13. Okay, so 13 and 20 should swap positions. These two guys should swap around. So 13 swapped up to here and 20 swapped down to there. And if you keep going, that's the next pass, that's the next pass, the next one, and the next one. And you can see it's all starting to get in very sorted order. We've only got 20, 18, and 19 to sort out. At the end, 18, 20, 19, we're nearly there. Now, this pass we're actually finished, okay? We've got them all in sorted order, but it will still do another pass, okay? It does as many passes as items there are in the array. So because we've got 10 items here, it's going to do 0 to 9 is 10 passes. So that's kind of another reason why it's inefficient, because it kind of doesn't stop at the right place. It keeps going until it's been through all the numbers. And there we are. That's our final sorted array. And that's all good. So that's selection sort. And although it was tricky to get that code working, it was kind of fun, because when you watch it come out here, you see, yeah, it's working. Yeah, I can see everything moving around and swapping around. And that was the algorithm. Yeah, it all works and I get a sorted list. Okay, this is kind of pure computer science stuff. We kind of find it a bit of fun. Application programmers might find it really annoying, because they'd rather just use, you know, the one-line VBNet sort or whatever comes with their interface development environment. Why do all the pain of this algorithm when it's already built into your programming language anyway? So challenge task 1 that we've got for you here is to modify that selection sort. So instead of doing numbers, it can do strings. So you'll just find you'll have to redefine some of the things. Instead of being integer, they're going to be string. And the one we're suggesting for you is a list of Grand Prix racing teams, so 10 of them. And so we've got Mercedes, Ferrari, Renault, Red Bull, Haas, McLaren, Alfa Romeo. So all of these are not in sorted order. Now, it's going to be hard to define them all across the page as an array, so use this long ways displaying. You've got 10 of them, so you need to define teams array with 10 locations from 0 to 9, so you put a 9 in here. So this gets really confusing. You think, oh, I'm putting a 9 in there, I'll only have 9 spots in the array, and when you count these up, oh, I've got 10 of them, so Racing Point won't fit in there. Yeah, well, it actually will, because that'll be number 9, and this one will be number 0, so they're all going to fit in there, and 9 actually means 10. So kind of get your head around that from all the work we've done on arrays previously. So what you should be able to do is something like this. Have the unsorted teams like that. Click the button to sort the data, and here they all are in sorted alphabetical order. Okay, so we can do it on strings and words and sentences, just not just numbers. So your challenge task is just to make a few changes to the program and get that all working for strings. Okay, so this finishes part 1 of the lesson. So you might want to take a break here. Remember what? Whoops, just banged the teacup and have a bit of a cup of tea as well. All right, so the thing is, you know, we make our lessons really long because we just want to sit down and do one session recording, because that's all the time we've got on the weekend to do it. We haven't got midweek time, so we've got this day job that's really filled us up and loaded us up with lots of extra work at the moment. But look, stop here, because that's selection sort done, and consider this as one lesson. Then you can come back and look at the video timeline index and do quick sort as a separate lesson, okay? Ideally on our YouTube channel, it would have been nice to just have them as separate lessons, but anyway, we're jamming it all into one lesson. So let's get on to part 2 now, where we're talking about a different algorithm called the quick sort. Okay, so this basically has 2 components, partition making and split grouping, all right? So it's a little bit more complicated, but just like that Grand Prix car, it gets a lot faster the more complicated it is. So this is one which would be good for large data sets. So once we've done the first lot of partitioning, we've got this number that's sort of somewhere around the middle, and that's called a pivot point. So we'll show you what we mean. Here's our starting off numbers, 4, 5, 2, 1, so they're not in sorted order. So you just start at the beginning here with the first one. All right, so just like kind of like we did with selection sort, we're just starting here with this first one of 4. And what we do with quick sort is the 4 ends up moved kind of around the middle here, because we work out what are all the numbers smaller than 4, and let's put them all to the left of 4. So when we go along, 2 smaller, 1 smaller, and 3 smaller than 4. So they all get put to the left here. And as we go along, we also note down which ones are bigger than 4, because we just decided 4 is our number because it's the one at the start here. So we had 5, 7 and 6. So they were all bigger than 4. So they end up to the right of 4. Okay, and this is called partitioning. What we've done is we've just taken 4 and decided let's find everything that's smaller than 4, put that over on the left, or at the top of the array or the start of the array. Let's find everything that's bigger than 4 and put that towards the end of the array, okay? So this is kind of the method for quicksort. And then we keep going. What we do now is we split off this left-hand part here, 2, 1 and 3, and we sort of work on sorting that separately. So we now work on each of these separately by picking the first number. So we go onto this one here. Let's pick the 2 and have a look at moving these either to the left or the right of 2, depending on whether they're smaller or bigger than 2. Okay, so 1's smaller, it needs to go to the left. 3's bigger, so it needs to be on the right. So we've now worked on this left-hand side separately and got it into sorted order, 1, 2 and 3. Then we work on the right-hand side separately. So 5's there at the start. Anything that's smaller needs to go to the left. Anything that's bigger needs to go to the right. Well, these are already bigger and they're already on the right, okay? And so we've actually kind of got that half into sorted order as well. All right, so if we now look at the whole array and assemble it back together, we've got that left-hand side, which we did separately, 1, 2, 3. We've got our 4, which we kind of put into the middle. Now, it won't always be exactly in the middle like this example. It'll kind of be somewhere around the middle. We've really simplified this just to show you, to get you and have an idea how it works. And then our 5, which was a pivot point for this guy, that's ended up like this. And now if you look at the whole thing, it's all in sorted order. So this is called a divide and conquer technique. What we did was we sort of had the whole thing and then we used just that first number that was in there to create some sort of midpoint that we could shift everything to the left and everything to the right. Then we've got a smaller sublist we can work on that left-hand side. So we apply the same kind of partitioning algorithm to that, do that one, and then split it again and again until it's all done, all right? So it's kind of like linear search versus binary search when we did those things. The kind of selection sort is the long way of doing things like linear search was. Quicksort is kind of more like a binary search. It's kind of splitting things up, dividing and conquering technique, okay? So in quicksort, we keep breaking them all down until we've got it all done. And the quicksort kind of did it the first time and then it calls the same routine the second time, but feeding in different data. So because it's in a routine calling itself back again, this is called recursion, and you'll kind of see this in the algorithm and the program when we show it to you. So this is getting quite complicated, but let's keep going with it. So the detailed explanation, if you want to see quicksort in action, this guy here, Abdul Bari, he does some really good videos. We were going to do a video here to show it to you in sort of animation, but look, it was going to take a long time and we figured out, well, how are we going to find time to do that with the day job Monday to Friday? And then we found this guy's video and we thought, wow, this guy explains it so well, it's even pointless for us to try and make a video to do it. All right, so I think his videos had like 500,000 views or something like that. So it's a good one, believe me. So you can watch that one there. That is a 13-minute watch, but that explains quicksort and the whole algorithm really well. And then to see it actually happening visually in action, like we were showing you a real simple one. Here's another one which puts these into sorted order using quicksort and just kind of shows it happening in order. So you could watch that maybe on 2 times speed with that link, and all these links will be in the video description. And this dancing video is really good. This one here of the Hungarian dance, where they are kind of in random order and then they ended up in sorted order as well with partitioning happening. That's a great video, and that's had 1.6 million views. So look, it's got to be the good stuff, which will show you what the quicksort algorithm is all about. Okay, now here is the actual quicksort algorithm. This came from the textbook we're using for our course this year, which is the Adrian Jansen software development textbook. And that's kind of your algorithm. Now, look, for our exams here in Victoria, with the VCAA, the software development exam, look, we haven't seen any exam papers where you had to memorize this and write it out. The thing is that you just need to know there is an algorithm for quicksort and have an understanding of how it works in your head with the numbers moving around, because that's what most of the exam questions seem to be on. And we're going to go through some exam questions later in this video so you can see that. So kind of don't have a meltdown right now looking at that saying, wow, I can't even really understand what that's doing, and how am I going to write that out, memorize it to put on the exam? Well, look, I'd say that there's no chance or very little chance that they'd want you to write that whole algorithm out on the exam, okay? You just need to understand how it works. Now, other subjects that are more pure computer science subjects, yeah, they might want you to understand the algorithm and be able to derive it or prove it and do things like that. So, you know, you need to talk to your teacher for your particular course in your country, wherever you are, and see what the requirements are if quicksort is part of your course. So challenge task 2, again, we didn't have time to kind of write a quicksort VB program ourselves, and we looked at videos, and this guy's video is great anyway, so we thought, well, why should we do one when he's already done one, which is great? So why not use this one and give him a bit of YouTube love and some more views? So yeah, if you watch this video, if you do want to write the program in VBNet, or if that's a requirement in your course or something like that, and you've got time, yeah, do this challenge task 2, watch that and write the program, and that should all be good, and you'll have a quicksort VBNet program as well. All right, so look, most of the sort routines, like we said, are already built into programs like that one-liner in VBNet. They use some variation of quicksort. Quicksort is sort of the main part of the sort engine they're using. So in VB, you know, you just have to do this, a one-liner to get everything sorted, okay? And what it does is it does a variation of quicksort running behind the scenes. Now, quicksort isn't actually the fastest sort algorithm. Maybe it's like a Ford Mustang or a Chevy Corvette with a big V8 motor in it that can go pretty fast and is pretty good, but it's not like a Ferrari or a McLaren. It's not kind of the super fastest of sorts, but for most people, that's going to be fine. Now, application programmers, you usually just use the built-in sort that's in your environment, okay? Or some special sorting utility program that you can run on your files first before they're taken into your program. So in the whole 15 years that I was working professionally as a programmer, the number of times I just had to actually look into a sort and sort of get it really working efficiently and knowing what it was doing in 15 years was maybe 3 times, okay? And I think 2 of those times I had guys from a performance team that were experts on this stuff helping me out with it, or kind of doing most of the work anyway. Okay, so if you end up in a systems performance team, if you're really hardcore computer science and that's your thing, yeah, sort algorithms and knowing all the different ones and how to derive them and how they work and all that sort of stuff is your scene, and that's real good. But for us application programmers, we usually just have to have the one-liner. So all that work we did with selection sort, what we can do is if we go back to our program there that was just sorting those 10 numbers and just rip out all that selection sort code, you can just replace it with this one-liner here, array.sort, sort that numbers array that we've got, and just display the answers in the list box, okay? So all your sort data button needs is just the one-liner of code, and VBNet will do it all internally, secretly using quicksort behind the scenes, and then you can display your answers. So look, that all works fine. There's the unsorted one. Bang, perfectly sorted, all right? So yeah, just try that out if you've done the other program, and you'll see that, yeah, sorting's not such a big deal. All right, so let's look at the exam questions, because we haven't done this for no reason at all. You're thinking, oh, Percy, why'd you show us all that complicated stuff when we can just do one line in Visual Basic? Well, yeah, it wasn't to kind of torture you or mess with your mind. It was to prepare for some exam questions, all right, on sorting. So let's have a look at this one. Which one of the following is a correct statement about selection sort versus quick sort for large files? Okay, now remember what we said about selection sort for large files. It's no good, okay? All right, a selection sort is normally faster than quick sort. No, that's wrong. It's not faster. So forget about A. B, a quick sort is normally faster than a selection sort. That is true, but then it's got this which uses a pivot. Okay, now I don't really like the way this question's been worded, but what it's implying here, because the which is closest to selection sort in that sentence, if you're a scholar of English, it's trying to say selection sort uses a pivot. It does not. Remember, it was quick sort where we kind of partition it and get that middle-ish point that is then becomes the pivot for splitting it in two. So B's actually wrong. The first part's right, but this part's saying that selection sort uses a pivot's wrong. So B, forget B. C, the algorithm for a quick sort produces fewer comparisons than the algorithm for a selection sort. That answer is looking very promising. D, so we'll just keep an eye on that answer. D, the algorithm for a selection sort produces fewer comparisons. Well, remember we said with a selection sort, we even saw it when we ran ours, it did that kind of extra 10th time at the end for no reason because it was already sorted on the 9th pass. A selection sort has to go all the way through, sort of doing what remains until nothing remains. Okay, so it's doing a lot of comparisons, and because you use this divide and conquer thing in quicksort, that actually uses much fewer comparisons. So the answer is C. And though I say, when in doubt, pick C. So on the actual Victorian exam that this was on, 53% of the exam candidates or students, a bit over half of them did choose C, okay, and got the right answer. But interestingly, 6% chose A and 11% for D, but 30%, 1/3 of the students chose B, which is a quick sort's normally faster. Yes, it is faster than a selection sort, and that was probably because they didn't understand this, which uses a pivot applies to the thing closest to it. So I don't like how this was worded because B was a very close second. You had to be an English scholar to know that it wasn't the right answer. Okay, so that's that one. And tricky question, you need to work through it carefully, okay? Because you might just be doing this fast and go, oh yeah, it's just a multiple choice, I'll do it fast. Oh, quick sort's faster than selection sort. Yes, it definitely is. Bang, I've got my answer. Okay, you need to read all of them and think about all of them. So lesson learned there. All right, question 2. In the process of sorting an array of 8 integers, the 8 whole numbers we've got shown there, which one of the following statements is correct? Neither 17 or 19 was the pivot. Okay, so pivot, straight away we're talking about quick sort here, and they even tell you that up the top. The pivot was either 17 or 19. The pivot was 17, but was not 19. The pivot was not 7, but it could have been 19. Okay, 17 and 19 have been put in the middle here. And if you look at either of them, 17, everything to the left is smaller. 17, everything to the right is bigger. Okay, but if you look at 19, oh, this is a tricky question. Everything to the left of 19 is smaller. It's the pivot, and everything to the right of 19 is bigger. Okay, so look, we really don't know. It's done one pass, the first partitioning. So 17 could have been at the beginning and it's been moved here, or it could have been 19 at the beginning and now it's moved there. Okay, we don't really know. I think B, the pivot was either 17 or 19, okay? And the correct answer is B, only chosen by 57%. So only about half the students that did the exam got that right. And you can see the other ones were almost kind of split evenly, although A, that's a bit of a worry that 1 out of 5 students said that neither 17 or 19 was the pivot. Well, you can see both those guys have been moved to the middle, and things are smaller and things are bigger. Bigger on the right, smaller on the left. So they didn't even know what quicksort was about. So anyway, if you can get this handled, you're well ahead of 20%, 19% of the students in the course, all right? So make sure you know these and you get them right on the exam. Question 7, the following array is sorted in ascending order. Now, it's not sorted in ascending order, it's actually unsorted at the moment. So I do not like this question, the way they've worded it. I think it should have said the following array is being sorted into ascending order at the moment, okay? Or it's in the process of being sorted into ascending order, because it's not sorted in ascending order yet. It's in the process of being sorted. But anyway, we've done 3 passes, so we're on the 3rd pass, and what we've got, we started off with that, but now we've got 6, 11, and 12. The first 3 are all in order, and they're all kind of at the start here. What's that sounding like? What does that kind of look like? Now, it should be pretty obvious that it's selection sort, okay? So binary search, well, it's not doing a search. They're talking about doing sorting here. It is sorted, okay? So they're not searching for a value. So C is the kind of get rid of that one straight away, and it's one of the other three. Now, bubble sort we haven't done. That was from the old course. The latest course uses quick sort and selection sort instead. So bubble sort isn't it, because that wasn't even in our course if you're in Victoria. And so it's quick sort or selection sort. Now, it is actually selection sort, and the third pass, because if this is the beginning, okay, marks the beginning, scans through, okay, 6 is the smallest, 6 swaps with 13, 6 would be at the start. Then it gets to here, blah, 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 11 would be the next smallest, so 11 moves to here, gets to the third one, 12 would be the smallest, 12 gets moved there. So we've had 3 movements of small items to the beginning, because we're on the third pass, definitely selection sort on this, okay? So that is it, but again, only a bit over half, 57% of candidates actually got that right, okay? There was still 23, 1 in 5 people thought it was quick sort, all right? So maybe, I don't know, maybe sorting looked really hard to students when they looked at it. They thought, oh, the algorithm and everything, oh, this is so complicated, and they didn't bother studying for it, okay? Maybe that's it, I don't know. But yeah, if you understand quick sort and selection sort, as you can see, these questions aren't too bad, and they're not asking you to write out code or write out algorithms or anything like that. You just have to understand in your head the pattern that's used for doing the 2 different types of sorting, and you should be fine on these exam questions, and they usually only have multiple choice on these. It's not a part B kind of longer answer or anything like that. Okay, so the following algorithm finds a given value of a variable in an array. But there's an algorithm here. Passy, you just said we didn't have to know algorithms. Well, let's have a close look at this question. It says it finds a given value. So it's not sorting, this is actually searching. So they love doing this, mixing up together searching and sorting questions, because that gets students confused, especially under pressure if they're not familiar. If they decided binary search looked too hard so they haven't studied it. If they decided sorting looked too hard in their course so they haven't studied it. So this one here, it's kind of got print found the ID of value. Now, none of the sorting stuff we looked at in our lesson looked anything like this, right? And it didn't print out that it had found some value or anything like that. So straight away you should be sniffing this out as being dodgy, and it's not a sort question, it's a search question, okay? So it's actually a straight, because it's putting the index up by 1 and kind of going, this one, the next one, the next one, the next one, have I found it yet? Have I found it yet? That is your good old linear search, all right? So this algorithm's nothing like a sort algorithm. Bubble sort in there, as we've mentioned. Bubble sort, the current software development course and the new 2020 course coming in next year are both going to concentrate on selection sort and quick sort. Bubble sort was in the old course. So if you wanted to look at this as a current type question, just swap that over to say selection sort, okay? Then you got the modern day question. But anyway, it's a search, and we're doing a linear search, not a sort. And the answer is C, which 64% of people, 2/3 more or less got correct, okay? So just be aware of that. They love to mix up search and sort and try and confuse you on exams. Not because they're nasty, I suppose, it's just because they want to see whether you really know your work or not. Sort out kind of the high scoring people from the other people. So that's it for this lesson. So remember, we do have the programming course, and there'll be information on that about this lesson and all of the other lessons that we've done so far in the course, programming. Now, we are planning on something new. We've always wanted to kind of do some Visual Basic games, develop programs for games. So we might be kind of swapping over a bit now and doing some Visual Basic little mini projects and games. So we might have a new thing here called VBNet Games or VBNet Projects or something like that. That's what we're thinking about for the next videos. And we're also thinking we might, for the foreseeable future, only be able to do videos every 2 weeks rather than every single week. So that's it for this lesson. As usual, it's been a long one, and we should have told you at the start, play the lesson at 1.5x or 1.75x speed using that cog on YouTube because we talk slow. But if you've been watching our lessons, hopefully you got used to that. So that's sorted. See what I did there? And that's it for this week. So look, that was kind of some pure computer science stuff, but it'll always be in courses. They love to put sorting into courses and memory allocations and stacks and queues and arrays and all this stuff. But when you get to your actual application programming these days, there's a lot of built-in things to help you out, okay? But you do sort of have to know the theory of how it works. A bit like a mechanic has to know everything that's under the bonnet, the real insides of it, what the bits and pieces and how it works, the alternator to start the car. But basically if the alternator isn't working, it's a matter of ripping it out and putting another one in and maybe send it off to an auto electrician that can recondition it or something like that, or maybe it just goes to scrap metal for the metal in it. But you know, that's the kind of way it is now. You don't have to, when you're studying computing, you have to get down to the nuts and bolts and know how everything works. But when you're actually doing it, you kind of get these built-in plugins and stuff like that. Okay, so I've ranted on long enough, and we'll see you. Subscribe to our channel, give this a thumbs up if you liked it, and we'll see you in the next lesson.